Welcome to Bexley Maths Test 2 Exam Papers Plus, question 17 onwards. Let's see how much we can do right now. You can turn me up if the volume is a bit too quiet. I'll try and talk a bit closer to the mic, so sound should be a lot better now. Let me turn this. Let me turn it like that. Yeah, much better. Here we go. A piece of paper is folded in half. The shape shown is cut out of the folded paper. Which one of the following shows what the shape will look like? I'm a bit confused why this question is in a maths paper. Maybe it's to do with line of symmetry. Maybe it's okay. I'm just thinking this should be in a non-verbal paper. Here we go. Now, what's the bit that stands out to me? Well, let's just go one section at a time. You see that bit? Well, we're cutting a piece of paper, so we're going to fold it out, and it will be symmetrical, that bit. Right. So that kind of looks like almost all of them, really. Well, maybe not that one. That looks a bit too thin here. But even if I'm a bit unsure, it's okay. It's okay. I think overall this has got to be symmetrical. Let me put blue here, that bit. Now, let me draw in the blue bit first. Now, A looks totally wrong because it's not symmetrical. That bit is a bit wonky. It's a bit sliding down. No. B, that bit, dun 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 dun, kinda, and now the red bit here, that looks okay. But then if we look on the other side, I don't think it's symmetrical. Dun 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 dun. No, it might be okay. Yes, it might be okay. Gosh, that matches up. Dun dun. Dun, dun, dun. So maybe B's okay. C. C. Dun, dun, dun. That looks okay. And then symmetrical. Yep, D. But that's a bit too long, that gap. That's going down this way. And E, I've chopped off. Now, E's not symmetrical. I know I have chopped it off, but it doesn't matter. So it's either B or C. Let me have a think. It's got to be symmetrical. Going down a lot. Let me put that in black. Down a lot. Down a lot. Yeah, okay. And then now across. Across and then up a bit. Dun dun. Ah, there we go. Up a bit. Dun dun. You see that? It's not going up here. There we go, B's the answer. And I know I was being silly with that. Let me show you here. Up top, there. Dun, 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 dun. That bit. See here, C is not going down. Dun, 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 dun. Because I was wondering, B or C, what's the difference? It's got to go down. Dun, 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 dun. There we go, B's the answer. Question 18. A triangle has angles x, y, and z. X is twice as big as y. Let's write it. X equals 2y. Oh, x equals 2y. And then now it's saying y, which is 3 times as big as z. I don't love the phrasing, but that's what it means. It's like carrying on, if we can see the orange bit. Y is 3z. So that's how we write it. One underneath the other. Now, why is William writing it like this? Because can you see the top, the red one and the orange one, they're the same. Y is the same in both. So now we make sure we compare y's. This bit, 2y is equal to 6z. Okay. Now it's asking angle y. It doesn't really matter what they ask for. We can work out everything. Now, we've got the setup. What do we know about triangles? If we add up all the angles, they add to 180. And they're telling us the 3 angles anyway. X, Y, and Z. So that's how we just combine everything. Let's just write it here. Now I'm going to flip it round because Z is the smallest. You know what? No, that doesn't matter. I don't want to confuse people. X plus Y plus Z is 180. We know that because angles in a triangle add up to 180. Oh, okay, so what, William? So what? There's so many letters, I don't even know what to do. Well, now we use these parts. Okay. X. What is x equal to? 2y. But then here 2y is equal to 6z, so really x is equal to 6z. Now y we can see is equal to 3z and z is equal to z. How nice. So that's the skill with this kind of question. Really, you're just moving everything. You're just making everything in terms of z. Just want to make that bit clear here. I think I was being a bit too quick. That bit. X is 2y, that green box. So 2y is 6z. Okay. Well, can you see they're both equal to 2y? So really, x is 6z. That's how I got that bit. Now, if we look at the left-hand side, how many z's are there? Let's add it all up. 6z plus 3z plus 1z is equal to 10z. This equals 180. So then, z is equal to 18. But the question is, what is y? Now, let's refer back to here. We can use this black box. Y is 3z. Okay, z is 18, so y is 3 times 18. So quickly do it if you're not sure. 18 times 3 is equal to 54. Good stuff. That is equal to y. Now, what they could have done is just say work out everything. Well, that bit is 54, and then you see the last bit is 6z. That's equal to x. Okay, so what? Well, we can work out the biggest angle. 18 times 6, just work out, that's 108. So if I quickly draw this triangle, it might look something like this. I know that's an equilateral triangle, it doesn't actually matter. That bit is 108. That bit is 54, and the top bit is 18. So there we go. If you add up all three numbers, no surprise, guys, no surprise, it will equal 180. Good. Question 19. The following formula is used to calculate a taxi fare. It says £5 plus 50p per minute plus 25p per kilometre. How long does a 10-kilometre journey that costs £17.50 take? So how long? And you can see the options are all in minutes. Normal formula question, let's just put in what we know. You see this bit, 10 kilometres. That is here. So put in. You see this bracket, bid mass, we need to work out each bracket. So that bit, 25p times 10 is £2.50. Okay, so that's that bit. Now, we're working out the minutes. Okay, so you see the other number, £17.50, let's put it here. So I'm just going to rewrite this a bit differently. Taxi fare, £17.50, just going to put this on the left. Now this is equal to £5 plus something we don't know at the moment, 50p per minute, plus £2.50. Let me just make this on the same line. Now look at the right side. We want to work out minute pretty soon, but what do we have so far on the right? We have £5 plus £2.50. What is that? £17.50. £7.50 I mean, and now we got this bit. Okay, now that I want you to think of it like this. It looks a bit confusing, but bear with me, it's only a couple more lines. That bit, think of it like £7.50 plus what is equal to £17.50. So this bit will be £10 is equal to that box, but remember that box is saying 50p per minute. So really, it's asking us how many minutes this journey took, but how do we move 50p to the other side? Well, when it says 50p per minute, that means times by 50p. Let's write that as well. Is it on the same page? Yeah. That is 50p per minute times by minutes. All right. So opposite to timesing by 50p is dividing by 50p. Let me write that again. Oops, should have got that on the same line. We're approaching 10 minutes. Short video today. Good. 50p times minute. Here. So now we work out minute. So you see this 50p. Move it over. We're going to divide. So let's just write that. Job done. I'll put that in blue. £10. divide 50p. Well, you see the top bit, just convert that into pennies, and 10 pound is the same as 1000p. 1000 pennies divide by 50p, a really nice way to divide. We can take off a 0 here and here, so treat this like 100. Let me get it on the same screen. Should I put it up top? Yeah. I'll make it black just to make it really clear. 100 divide 5 is equal to what? It's equal to 20. So there we go. This journey, it took them 20 minutes. Good. We're 10 minutes in, job done. So we have covered up to question 19, the normal way I end this video. Let's cover the screen. Good stuff. In the top left corner, it will be the previous video, and you know what, maybe in the bottom left corner it will be the next video, just to keep the students keep watching these kind of maths videos. Okay, that's it for now. Thank you for watching. We're 11 minutes in, job done.